Let me tell you a story. A story about how we moved from complex biological data to real therapeutic hypothesis and experimental validation. This is a story of our work in Treatment of IBD project. Inflammation in IBD is not just a list of genes. It behaves like a fire. Once ignited, it sustains itself through positive feedback loops. And if you only look at individual genes, you will never understand why this fire keeps burning. So we ask a different question. What are the causal mechanisms that maintain this inflammatory state? We applied our upstream analysis approach. Step 1. We started with gene expression data from multiple IBD model systems, human monocytes, gut organoids, xenografts, patient biopsies. Step 2. We analyzed promoters of differentially expressed genes to identify transcription factor binding site combinations, not single transcription factors, but composite modules, because gene regulation is combinatorial. To detect these combinations, we even developed a genetic algorithm. This allows us to reconstruct the regulatory logic behind the data. Step 3. We moved upstream from transcription factors into signaling pathways. Using curated knowledge from Transpath, we reconstructed the causal network driving the inflammation. And this is the key idea. We don't just look at correlations. We moved upstream to identify master regulators and true drivers of the disease. And what we found was really striking. The NF-kappaB network is not just activated as trivially you can think, it is dynamically sustained by positive feedback loops. From this analysis, we identified a comprehensive list of 150 potential targets within this network. Some were known, but many were quite new. And importantly, they were not just random lists of genes. They were mechanically connected through the same regulatory system. Then we asked, can we actually interfere with this system? And using our chemoinformatics tool PASS, we screened millions of compounds from synthetic libraries, natural compounds, and known drugs. And here comes the interesting part. From the top candidates, we found something unexpected. Macrolide antibiotics. They are not designed for IBD, not developed for inflammation. They are antibiotics, but they were predicted to interfere with NF-kappaB dynamics. And this is the power of causal systems biology. We don't just look at what is obvious, we discover what is hidden but logical. And then we tested it in vitro using TNF reporter assay and in vivo using mouse models of IBD. The results were clear. Clarithromycin. It significantly reduced NF-kappaB activity. In IBD models, less weight loss, reduced inflammation, improved histology. So, what did we achieve? We started with various data. We reconstructed the regulatory mechanisms, we identified master regulators, we predicted drug candidates, and we invalidated them experimentally. This is not just analysis. This is a pipeline from data to therapy. And today, this entire workflow is implemented in Transfac disease package ready to use. If you want to move beyond correlations and understand disease causality, then you need to go upstream. You can tell us about your problem by filling out the form. The link is below the video, and we'll try to explain how we can help. If your issue is more complex, simply tick the box in the form, and we'll arrange a Zoom call and talk personally. Stay tuned, and goodbye.